Alright, let's take a look at the elevator problem. So we have a elevator and there's a person standing inside the elevator that weighs 60 kilograms, whose mass is 60 kilograms actually. And the acceleration of the elevator relative to the ground is 2 meters per second squared. The person is standing on a scale and we want to know what will the scale read. So this is going to be a F equal ma problem. MA. And so you might be tempted to just go into the forces. You can't do that until you know what your system is going to be. So you always write your system down next to the equation so that your teacher knows what your system is. So let's see. You can choose what you want to make your system. That's understand that nature doesn't have a system. That's why you get to choose what you want to make your system. Okay, so you can make everything your system, but if you do the problem out as everything as a system, you'll realize it won't work. So there's a system that can make this problem solvable, and that person is gonna be, or that system is gonna be just the person, because that's the amount of given. Because with this amount of given data, we can do that. And you might be asking, well, how do I know that? Well, once you do enough problems, you'll understand that. So, okay, you know what? I'll make everything as a system. Everything. So, there we go. So let's see. So if we take a look at the equation, what Newton's second law is saying, the net external force on a system is proportional to the mass of the system and the acceleration of the system. So if everything is the system, how can you have a net external force? You can't. There is no net external force, so it's zero. How are we going to then solve for normal force? You see, so we can't do that. So let me erase. Okay, then you're like, okay, well, maybe just don't make everything the system. Alright, let me make the system just the person and the elevator. So let's say we write all our forces down. Oops, whatever. And then equals, so now we're on the right side of the equation. So we're going to have mass of the person, the acceleration of the person relative to the ground, plus the mass of the elevator, acceleration of the elevator relative to the ground. Okay, we have the mass of the person, acceleration of the person relative to the ground. We can get that. We can get the acceleration of the elevator relative to the ground. Remember, it's given. But how about the mass of the elevator? How are you going to get that? You can't. That's why this system cannot work. You can't solve this, the problem with this system. So that's why now let's try just the person as the system. So okay, so let's figure out what our forces are then. If I look at our diagram on the left side, so there's going to be the force of gravity onto the person, acting on the person, and there's a normal force of the elevator or the scale, but let's just say the elevator and the scale, they're basically just the same thing. So the elevator onto the person. Okay, so when you're deciding your forces, with the exception of gravity, there must be a contact force. There must be contact for there to be a force. When you go to more advanced levels, you'll know there's actually, it's not just gravity, there's more going on, but mechanics class, just gravity is a non-contact force. Okay, so we have our two forces down, nothing else. So now let's write it down. Force, the normal force of the elevator on the person plus the force of gravity on the person equals mass of what? Mass of the system. The system is just the person. Acceleration of our system acceleration of the elevator, or no, acceleration of our system, which is just the person, relative to the ground. Now, in this case, the acceleration of the person relative to the ground is the same as the acceleration of the elevator relative to the ground. So we'll write that down on the next line. But now we need to get rid of the vectors. So we need to convert it to scalars, our entire equation into scalars. And to do that, we need to have a coordinate system. So what's up, what is down? So I'll write it right here in blue. So what's up and what's down? That's a trick question. You can make up whatever you want. You can make down whatever you want. You can make up positive if you want. You can make up negative if you want. Remember, nature doesn't have a coordinate system. So to prove my point, I'm going to make up negative and down positive. Alright, so then let's continue and convert to scalars. So the normal force of the elevator relative to the person, so that's pointing up. And if you remember, up is negative. So negative normal force of the elevator onto the person plus, how about the force of gravity? So if you take a look, the arrow is going downwards and down is positive. So plus force of gravity onto the person equals mass of the person. Okay, this is where you can mess up. This is a vector, acceleration vector. We have to convert it to a scalar. So you can't just write acceleration of the person relative to the ground. You need to write the sign as well. So acceleration of the elevator person relative to the ground. Or actually, yeah, we discussed that. It has to be the same. So the sign, the acceleration of the elevator relative to the ground, well, it's going up, and up is negative. So we write negative. Alright, now we just need to solve for the normal force. So I'm going to move it to the right side. Equals, and then move this to the left side. Mass of the person, acceleration of the elevator relative to the ground, and the force of gravity on the person, so that's mass of the person times g. Okay, so now you just plug it in, just plug in your numbers. So we have 60, so the mass of the person was 60 kilograms. Acceleration of the elevator relative to the ground, 2. Wait, is it minus 2? Because up is negative? No, it's not. We already took care of that when we converted from vectors to scalars. So you don't write the minus. Do not write the minus in. Okay. Plus, so mass of the person again, 60 kg, and then 9.8. Actually, I'll make it 10 just so I can do the calculations in my head easier. Equals the normal force. So then 120 plus 600 equals normal force. So the normal force equals 720 newtons. So this is what the scale is going to read. So the scale over here is going to read 720 newtons.